Hello everyone, welcome back to our channel. I am your maths teacher CG ma'am. We are continuing exercise 12.3 problem number 11. I hope all the previous videos are very clear to you. Okay, if you have any doubt, please do remind me, I will clear your doubts. Okay, now we are moving to the 11th problem. Okay, let us start. So here in the 11th problem, we have a handkerchief and 9 circles are printed. Okay, and we have to find out the area of the remaining portion. Okay, so after subtracting the area of 9 circles, you will get the area of the remaining portion. These are the area of the remaining portion. Okay, so for forming or framing the equation is very quite simple, because now we are in the 12th problem. We already have familiar with such type of problems. Okay, so we have to subtract area of 9 circles from area of the square. But what is given in the question? We have given only the radius of each circle. Okay, that is radius is given as 7 centimeter. In order to calculate the area of the shaded region, that is area of the 9 circle should be subtracted from area of the square. Area of the square is side into side, but side is not given. Okay, and since this 3 circles, that is 3 circles in each row, each column. Okay, so the sum of the diameters of 3 circles will be equal to the side of the square. Is it clear, children? That means this is the diameter of the first circle, second circle and the third circle, and these 3 diameters sum will give you the side of the square AD. Likewise in the row wise, okay, this and 3 will be equal to side AB. Being square, all sides are equal. So side of the square AB can be represented by small letter a, will be equal to 3 into diameter. And since radius is 7 centimeter given and diameter will be 2 into r, okay, that is 14 centimeter. That is the diameter. So side will be 3 into 14 and that is equal to 42 centimeter. This is a side. The next is very simple. Okay, we have given the radius of the circle, that is 7 centimeter. Then next step is simply the calculation. Okay, we are writing the equation for the area of the shaded region, that is the remaining portion. Area of the remaining portion, okay, that is A is equal to area of the square, A square minus 9 into pi r square. Each circle of same radius. Okay, that is the design of the handkerchief. So 9 times area of one circle, that is 42 into 42 minus 9 into 22 by 7 for pi into radius is what is radius? 7 into 7. So 7 get cancelled. In the second term, 7 and 7 get cancelled. So the remaining numbers in the numerator will be 22 into 9 and 7 will be 63. We have to get the product, and here also 42 into 42. 42 into 42 is 2 2s are 4. Okay, and 8 and 8 16, 1764 minus, okay, here 2 and 3 6, okay, and 12 18 1 carry, okay, and the next is 18 1 carry, that is 1386. Okay, subtracting you will be getting 17 1764, we can subtract over this side, 1764 minus 1386. Okay, so 8 on borrowing. Okay, then 5, 7. Okay, then 6, that is 378 centimeter square. This is the area of the remaining portion. Hope this is very simple calculation. I hope this is also very clear to you. Okay, now we are moving to the next problem. Yes children, in the 12th problem, we have given a quadrant OACB. Okay, and since it is quadrant, okay, this is 90 degree. Okay, this will make 90 degree. Okay, and here we have to find out area of this shaded region. That is very simple. If you subtract, okay, from this area of this quadrant, this right triangle, right, this right, why it is right triangle? 90 degree, because it is quadrant. Okay, that is right triangle BOD. From area of the quadrant, you will get the area of the shaded region. So this question also having two parts. In the first part, we have to find out area of the quadrant OACB. Okay, being it is quadrant, area is equal to pi r square by 4. That is 22 by 7 into radius. What will be the radius? Radius of the quadrant here is equal to OA or OB, and that is given as 3.5 centimeter. Here OB is given because from center to any point on the circle. Here, since that is A and B are on the arc or on the circle, half 1/4 of the circle is quadrant is given. That means OA or OB will be the radius with respect to the quadrant. Okay, so that is given as 3.5 centimeter. So 3.5 into 3.5, okay, and here 4 is there. Okay, 4 divided by 4, that is 22 by 7 into 4 into 3.5 into 3.5. Okay, we can do the calculation very simply. Easily you can calculate. That is 22 by 7 into 4 into 35 by 10 into 35 by 10 to make your calculation more easy. Or you can calculate, reduce 7 with 3.5, 0.5, likewise also no problem. Okay, so 4 here is 11, 2 remainder. Okay, this here 7, 5 times. Okay, 7 5s are 35. And 11 into 5, 55 into 35 comes in the numerator. Okay, divided by 2 into 100, that is 200. 2 into 10 into 10, 100. Okay, so okay, now in the next step we are going to simplify 55 into what is that? 35. That is 25, 2 carries, that is 15 and 40, 25, 40 and 2, 42, then 4 carries, okay, divided by 200. Okay, that is, can we write like this to make our calculation? Okay, my aim is to make your calculation so easy. For that I am right. Let us see how this can be easily done. 2 into 100, right? So 2 decimal places should be shifted to left side in order to divide with this. So can we write like this? 19.25 by 2. Okay, we divided with the 100, so 2 decimal places, so 19 point. Then you divide with the 2. That is 9, 2s are 18. Okay, then 1 carry 6. Okay, then 2, 5. Okay, this is the area of the quadrant. Area of the quadrant 9.625 centimeter square. Okay, and in the next second part, what is asked? Area of the shaded region. In order to get area of the shaded region, you have to subtract this right triangle BOD. Okay, right triangle means you can definitely use half BH. Okay, base is given as 3, you can take as the radius of the quadrant, that is OB, and the height, because we need the triangle, okay, up to this, the perpendicular, that is OD, that is 2 centimeter, that is given. Okay, so in order to get the area of the shaded region, you have to calculate first, that is shaded region will be, area of the shaded region will be pi r square, area of the quadrant minus half BH formula, that is area of the right triangle. That is, we have seen this is 9.625 minus half into base, that is 3.5, and its height, don't write 3.5 over there, that is OA, okay, but it's a right triangle, so up to OD, that is 2, 2 get cancelled, okay, that means 9.625 minus 3.5, okay, so minus 3.5, okay, so here comes 5, 2 and 1.6, that is 6.125 centimeter square is the area of the shaded region. Okay, if you subtract area of the right triangle from area of the quadrant. Okay. Now we are moving to the next problem. Yes children, 13th question we are going to solve now. Okay, this is one of the important question, another important question. So here we have given a quadrant of a circle, okay, and we have to find out the area of the shaded region. So very simple question, but we have to find out what all things are required, okay, then only you can easily calculate the area of the shaded region, okay. So here we have, you can see a square is there inside the quadrant, and if you subtract its area from the quadrant, you can easily calculate the area of the shaded region. Okay, yes children, if you know the exact shape of the shaded region, you can directly use that one. Okay, we have seen in one of the problem, I think 9th problem, there we have know the area of the segment, okay, 2 segment, and area of the inner circle, because all the shapes are known. Okay, the shaded shapes are known, but here this shape is not known. Okay, that is why we are subtracting another method by subtracting the known shape from the another known shape, that area of the another, that is quadrant. You can, the remaining portion will be the area of the shaded region. Okay, so here you have to subtract area of the square. Here area of the square is here OA equal to AB is equal to ABC equal to OC. Side is given, that is 20 centimeter given. So you can easily calculate area of the square OABC is equal to 20 into 20, that is 400 centimeter square. This should be subtracted from area of the quadrant. What is area of the quadrant? Pi r square by 4. But radius is not given. We have given only the length from O to OA, that is side of the square. But here the radius is OP or OB. But why the radius? By definition, the line segment joining center to any point on the circle. Here A is not the point on the circle. Okay, here the point is here P. Okay, OP and OB and OQ, all these are the same, because being they are radii of the same quadrant or same circle. Okay, so that is why I am going to, in order to get that radius of the quadrant, okay, in terms of the square, you will get if you join OB, because OB is nothing but the diagonal of the square. Okay, and by formula, what is diagonal of a square? Root 2 into A. If you, those who know that formula, you can directly apply root 2 into A, or you can apply the Pythagoras theorem, because each angle of a square is 90 degree. So right triangle OAB by Pythagoras theorem, OB square is equal to 20 square plus 20 square. That is root of 2 times 20 square, that is 20 root 2. Or directly you can write the radius of the that is diagonal of the square, diagonal of the square, diagonal of the square, this is a formula, okay, root 2 into A, and A is nothing but the side of the square, that is given as 20, that is that is 20 root 2 centimeter, or by Pythagoras theorem. Okay, OB is the square of the hypotenuse, so square of the hypotenuse OB square is equal to 20 square plus 20 square, and root of 2 times 20 square, so 20 root 2. Both ways you will get answer as 20 root 2 is the radius. That is, next step we are going to calculate the area of the quadrant. Area of the quadrant, okay, that is A is equal to pi r square by 4. That is, we have to substitute the value of pi as 3.14. 3.14 into radius we have got 20 root 2 into 20 root 2 divided by this 4. Okay, and 3.14 into 20 into 20 into root 2 into root 2. So 20 400 into 2. Okay, that is 800 divided by 4. That is 4 in 800, 200. And see the next calculation. I will make you more easy. 3.14, 200 can be written as 2 into 100, right? Okay, so multiplication you will get 314, 2 decimal poi kazhinju. Okay, so 8, 2 and 6, that is 628 centimeter square. This is the area of the quadrant. Okay, from this you have to subtract area of the square, that will give you the area of the shaded region. So in the next step, area of the shaded region equal to pi r square by 4 minus a square. Area of the quadrant minus area of the square, that is 628 minus 200, that is 400, 20 into 20, that is 228 centimeter square is the area of the shaded region. We are going to start the 14th problem. This is very simple problem, but so many times this question also asked for the board examination. Okay, so here we have to again find out the area of the shaded region. For this, it is very clear, this is a region enclosed by 2 radii and its corresponding arc. That means we have to apply the concept of sector comes. So the area of the sector, okay, that is, if you subtract this sector, consider the sector COD. COD is a part of a 2 concentric circle. Okay, same center. Okay, and angle is 30 degree, theta is given as 30 degree. Okay, and CD, CO and DO are the radii of the small sector. Okay, and the another sector is AOB. Okay, so area of the big sector AOB minus area of the small sector COD will give you the area of the shaded region. Okay, so we are, because we know the direct formula for the shape, that is the sector, we can easily apply that formula, okay, in order to get the area of the shaded region. Okay, so area of the shaded region A is equal to area of the sector AOB minus area of the sector COD. Okay, that is theta being the constant part of a concentric circle, okay, with the same center and angle between the radii are the same 30 degrees. So theta by 360 degree, okay, into pi capital R square. Capital R I have given for the radius of the big sector, that is given as 21, that is OA or OB, both are the same. Okay, minus theta by 360 degree pi small r square. Okay, so area of the sector, big sector minus area of the small sector. So theta by 360, pi can be taken outside. So theta by 360 into pi and capital R square minus small r square comes in the bracket, remaining terms in the after taking theta by 360 into pi as common. Okay, so we have seen that capital R as 21, small r. So a square minus b square, a plus b into a minus b, that is 30 theta value is given 360 degree, and for pi 22 by 7, and we are going to substitute capital R plus small r, that is 21, 28. 21 minus 7, that is 14. Okay, a plus b into a minus b. So 30 in 360, 12 times. Okay, 0, 0 get cancelled, 3 in 36, 12. Okay, and 7 and in 14, 2 times. Okay, and here 2 and 6, 2 get cancelled. Again 3 comes, here comes 14. That is for 22 into 14 remaining in the numerator, divided by 3 alone in the denominator. On multiplication, 4 into 2, 8. Okay, then 2 and 8, 0, 10, and 1 carry 308 divided by 3 centimeter square. This is the area of the shaded region. Just subtracting the small area from the area of the big sector. Okay. So here this problem, from seeing the figure, it is very clear, and also the shaded region is marked. Okay. So it's very carefully notice what will be the area of the shaded region. Here if you close this portion, okay, and here BC will be the diameter of this semicircle that is given. Okay, and if you subtract this from this semicircle area, if you subtract this portion, that means the area of the segment. That means this is the portion I am talking about now. Okay, that means from the semicircle, that is BCQ, outer arc. Okay, BCQ, from the semicircle, if you subtract this area of the segment, that is this black shaded lines, okay, you will get to the area of the shaded region. Okay, this is what I meant. Okay, this is the black shaded portion, and this is the semicircle. Okay, and from this semicircle, if you subtract this area, that means this will be the area of the segment. This is the area of the segment for 90 degree. Okay, that means you will get it. You can easily calculate the area of the shaded region. Actual shaded region is the red lines. Okay, so first step is we have to find out the area of the segment for 90 degree. Okay, so what is that? That is 2 by 7, or for 90 degree pi by 4 minus 1 by 2 into r square. Anyhow, radius need to be calculated, but radius is not given. In the figure we have given, we have given AB is given. Okay, AB is from A to any point on the circle. Okay, and for this quadrant AP, that is radius, can be taken as 14. Okay, then the AC also 14, that is given. So radius of this quadrant, for calculating segment, you can take a radius is given as 14. Okay, that means we are going to calculate the area shaded with black. Okay, that should be subtracted from area of the semicircle. Okay, then you will get area, actual area to be found. Okay, so that is area of the quadrant, that means area of the segment. Okay, that is area of the segment when theta is equal to 90 degree, because quadrant 90 is understood. Okay, that is A is equal to pi by 4 minus 1 by 2 into r square. And we have seen that this is 2 by 7 into 14 into 14. Okay, that is here 2 times, that is 4 into 14, that is 56 centimeter square is the area of the segment. If you subtract this from area of the semicircle. BC here act as the diameter of the semicircle. So, area, to get the area of the semicircle, that is pi r square by 2. So, that radius and the area of this quadrant, or that if r we used to calculate area of the segment, okay, both are 14 centimeter. That is not for the radius of the semicircle. Okay, here semicircle BC is the diameter. Okay, so we have to take its half, but BC is not given. Okay, children, that point is clear. BC is not given. Okay, that can be easily found by using Pythagoras theorem, by considering right triangle. What is that? ABC. Okay, right triangle ABC, in order to get the diameter of the semicircle. Okay, semicircle, that is BC square is equal to, what is that? AB square plus AC square. Okay, that means AB is 14 square plus 14 square, that is this will be 2 times 14 square. So, from this you can easily calculate BC will be the square root of 2 into 14 square. We know that root A into root B can be splitted. So, root 2 into root of 14 square get cancelled. So, 14 root 2 will be the diameter, that is BC we have taken as the diameter of the semicircle, 14 root 2. Okay, so area of the shaded region A is equal to, what is that? The total area of the semicircle, pi r square by 2. Its radius and the radius of the quadrant are both are different. Okay, so that we have seen the diameter as 14 root 2 implies radius is equal to 14 root 2 by 2, that is 7 root 2. Okay, so radius is equal to 7 root 2 centimeter for the semicircle. Okay, minus, what is that? Area of the segment, we have seen that 56 centimeter square, that is 22 by 7, and in the denominator 2, 7 root 2 into 7 root 2 minus 56, isn't it? Okay, so in the final calculation, the final step, it will be, okay, so 2 this 2 11 times, okay, so this 7 and 1 7 get cancelled, so the numbers remaining 7 into 11 77, root 2 into root 2 2, okay, nothing is there in the denominator, minus 56. That means 150, that is 14, 1 carry, that is 154 minus 56, that is 98 centimeter square is the area of the shaded region. Yes, children, now we are in the last problem of this exercise. Okay, that is 16th problem. This also one of the very important problem. Okay, the last 4 problems are very important. Okay, now here we are asked to find out the area of the design. Okay, here the design is obtained by adding the quadrants. That means if you quadrants means this is 90 degree, right? Okay, that means with respect to this one, this is the quadrant. That means this D, B, this is the quadrant. Okay, and this portion is shaded. Okay, so with respect to this side quadrant, okay, that is the area, and of the other side, upper side will be the, for this quadrant, this is the area. These two areas will give you the area of the design. Okay, so in order to get this area, okay, so this is the area between the chord and its corresponding arc with respect to this quadrant. Okay, and both having the same length, that is 8 centimeter, okay, quadrant. Okay, so in order to get this area of this design, this will be the area of the segment of this quadrant. 2 quadrants are attached. Okay, and these two will give you the sum of these two shaded region portion will give you the entire design, area of the entire design. Okay. So, with respect to first quadrant, this is the area of the segment. With respect to the second quadrant, this is the area of the segment of the second quadrant. So, we have radius that is given as quadrant, radius of the quadrant that is given as 8 centimeter. Okay. So, area of the design will be 2 into area of the segment, that is 2 into pi by 4 minus 1 by 2 into r square. Okay. That is 2 into, I told this will be 2 by 7, and what is r square? 8 into 8. Okay. That means 2 2s are 4 by 7 into 64. Okay. That means 64 into 4, that is 16, 1 carries 256 by 7 centimeter square. This is the area of the design. I hope this is quite simple. When you take the cutout, okay, of a quadrant and emboss the another quadrant, okay, so this will be the common between two quadrants. The same idea, the same answer you will get in this case also. Okay, you just join the diagonals, okay, so that you can treat this as a quadrant and you can treat this as a segment. That is, this diagonal will give you the idea of chord, okay, with respect to the quadrant. Okay, that is chord and its corresponding arc, and this side also the same idea comes. Okay, that is that corresponding arc and a chord. Okay, so this sum will give you the area of the design. This is all about our exercise 12.3. I hope all these problems are very clear to you. Okay, so study well and we will meet you with another new lesson, okay, in the next video. Thank you for watching and supporting me. Thank you all.